Hi guys, welcome back to the Art of Server. This video is part 5 of a series of videos where I'm testing the power consumption of LSI HBA SAS controllers, such as the one you see right here. What you're looking at here is my HBA power consumption testing rig, and if you'd like to know more about this, I've made a separate video going over the details of this setup. I'll leave a link to that video in the corner right here. In part 5, I'm testing the power consumption of 8 external SAS lane controllers. This will cover the 2nd generation 9200-8E, the 3rd generation 9207-8E, the 4th generation 9300-8E, and the 4th generation 9400-8E. I'm skipping over the 1st gen, and there was never a 5th gen external port card that I know of. And also, I don't have any of these newer 7th gen and 8th gen external port HBAs as they're simply too expensive for me. Now, to do a quick recap on how I'm testing the power consumption, the HBA is plugged into this PCIe interposer board from Elmore Labs. This board cuts off power from the motherboard and supplies it through this 6-pin PCIe power cable, which is metered on this device over here, which is the Elmore Labs PMD2. This line here that says PCIe will indicate the power consumed by the SAS controller. So I'll keep a camera on this PMD2 so you can see the reading while I'm conducting the test. Now, to see how power consumption is affected by I/O load, we're also going to run a FIO 4K random read load test using these 8 SAS 3 SSDs. These SSDs will allow us to generate a load of roughly 1.5 million IOPS. This should be an appropriate load for the controllers we have today. Now, if you're interested in the power consumption of internal port LSI HBAs, check out my previous videos in this series. I'll leave links to those videos in the description. And also, if you want to know the power consumption of 16 external port HBAs, subscribe to my channel and stay tuned for those videos in the upcoming weeks. And if you only want to see the test results for a specific card, I'll leave timestamps down in the description so you can go ahead and skip to whichever test interests you the most. All right, let's get started. All right, guys, we're booted up with the 9200-8E card right now. So let me go ahead and first show you that card is visible here. And so, yep, here you can see it's based on the SAS 2008 chipset. It is the LSI SAS 9200-8E, and this is the firmware that's on that card right now. All right, so as a baseline, we can see that right now we're sitting at about 6 watts, which is about the same that we saw with the 9211-8i, based on the same chipset. And if I run ls SCSI, you'll see that we can see the 8 SSDs that are connected to that card. And as I mentioned, we're going to be running a 4K random read IO test using FIO. And so here is the script that I've set up for this test. So if you want to see the settings, go ahead and freeze the video here to look at the settings I have. And at the bottom here, you'll see that I have it set up to run on drives SDA through SDH. All right, so again, right now we're idling at about 6 watts. So let's go ahead and run the load test. So it's shot up to about 7 watts right now, and we're seeing about 400. Well, now it's dropped a little bit, but okay, now it's back up to about 420, I guess right now. Okay, yeah, so a little bit above 400,000 IOPS. And I'm also recording the LED activity on this card. I'm a fan of blinky lights, what can I say? So I'm going to share that with you guys in the final edit of this video here. So you'll see all the activity going on. We're over 420,000, 440,000 IOPS. All right, so, and now we're back down to 6 watts. So this is, again, fairly typical. It's very similar to what we saw with the 9211-8i card. And the performance here is actually pretty impressive. So at the end here, we got an average of 412, almost 413,000 IOPS. And the bandwidth throughput was about 1.6, maybe close to 1.7, maybe gigabytes per second. All right, so let me go ahead and shut this down. We'll go on to the next card. All right, so what we have here is, well, it's actually an HPE H221, and it's labeled 9205-8i, but it's actually a SAS 2308 chipset with Rev D1, which supports the PCIe 3.0. And so this is basically equivalent to a 9207-8E, and that's what I'm going to be using today to test this generation of chipset. And if you want to know more about the H221, go search on my channel. I've talked about this card several times. I used to think that this was a Rev B0 only controller, but I found some samples out there, and this is one of them where it actually has the Rev D1 chipset, which is the one that the more modern one that supports PCIe 3.0. But anyway, we're going to test this out. Okay, so we're booted up. Let me run SAS to flash to show you the card is here. All right, so as you can see, this is a SAS 2308 chipset with the Rev D1 revision, and that's the one that supports PCIe 3.0. And it has the firmware from the 9207-8E, but this actually is a HPE H221. And furthermore, let me show you the PCIe link status information. Oops. All right, so here is the controller, SAS 2308, and you can see that the link capability is the speed is 8 gigabit transfers per second, so that's PCIe 3.0, and indeed the link status is 8 gigabits or 8 gigatransfers per second. So all right. Anyway, the 8 SSDs here are still the same, A through H. All right, so I'm set up to run the file test here. So let's take a look at the power consumption. Right now, it's sitting at about 10 watts. So, well, it's fluctuating between 9 and 10 watts, but it's spending more time at 10 watts. So if I recall correctly, the 9207-8i, the internal version of this card, was maybe 1 or 2 watts less. So it seems like this card is consuming a little bit more power, maybe like 1 watt more. All right, so let's see what happens when we run it under the 4K random read IO test. All right, so we are at about 10 watts, and here we go. Okay, so we're only at 432,000 IOPS, and we're sitting at a solid 10 watts. That seems really unusual, because I think this card should be able to handle about 600 or more thousand IOPS, and I'm not really sure why it's not. Yeah, this is not looking good for this card. Okay, so we ended up with an average of 420,000 IOPS. Like that's about that was close to the previous card, the 9200 previous generation card. So not sure why that is. That's really strange. And the power consumption didn't really change much. I think it went from hovering between 9 and 10 watts to a solid 10 watts, so it's maybe a half a watt difference or something like that. I'm not really sure why this is performing this way. This is kind of strange. I kind of feel like I want to go get a genuine LSI 9207-8E and see if we get the same behavior. I wonder if there's something special about this HP version. Okay, so let me go ahead and shut down, and I'm going to go find a 9207-8E that's just a plain LSI version. All right, guys, so here I've already removed the H221, And this is a genuine 9207-8E, and you can see on the back, or right here, I don't know if you can see that, but it says 9207-8E. All right, so let's try this out and see if we get different performance numbers. Okay guys, well, off camera it was some time has passed, let me just put it that way. The LSI, the genuine LSI 9207-7E card, or 8E, 9207-8E card, did not want to be recognized in the Elmore Labs PCIe interposer board that measures the power. So I had to do what I did in the very first video when I had similar problem like this, and I had to manually set the PCIe link speed to PCIe 2.0. So let me just go ahead and kind of show you guys that. All right, so the card is recognized now. At one point it didn't even show up, so you can see that it's there. And let me get the PCIe address and let's take a look at, so you know the card's right there, right? And link capacity or capability is 8 gigatransfers, but you'll notice link speed is now at 5 gigatransfers, and that's the only way I could get this card recognized. So I'm going to go ahead and run the benchmarks. We'll see what numbers we get. I'm also going to install this card in a regular PCI slot, which I believe it's not going to have any problems working in, and then we'll rerun the benchmarks just to have some comparison of how much the PCIe link speed affects the file numbers, but I won't be able to get the power rating. So anyway, just going to mention that. So anyway, let's run SAS to flash just to show you so the firmware is the exact same firmware as on the H221, but this is a genuine 9207-8E, not a HP version of that. But for whatever reason, this one seems to be finicky. The HP version had no problem in that the PCIe interposer board. So anyway, you can see everything there. Let's see, the 8 SSDs are connected, and let me just set up for running the file load test. And we're looking at a pretty solid 9 watts right now. So that's interesting that the HP card was hovering a little bit higher, kind of more in the 10 watt territory. But this one is pretty solid in the 9 watt territory. Okay, so not sure why that was, but let's go ahead and run the file load. Okay, so as soon as the load test started, we're up at 10 watts. And you can see that even right now we are above 500,000, climbing a little bit, 500,000 IOPS. So that's at least 100,000 IOPS more than what we were seeing with the HP card. And both of these have the same chipset, so that is really, really strange to me. And this one is limited at PCIe 2.0 speeds, so I'm curious as to what kind of numbers we're going to get when I put that in a regular PCI slot. So yeah, it's still sitting at 10 watts. And we're almost done here. Okay, so we are done. And the power is now down to 9 watts again. So I think that is fairly typical of what we saw with the 9207-8i card in the first video of the series. So all right, so what do we have here? Average IOPS came out to 532, almost 33,000. And that's a little bit lower than I think the specification, which I think is spec'd at about 650,000 IOPS. And so again, I'm not sure why these cards seem to not be performing as well as I would hope. But anyway, at the end of this video, we'll look at all the numbers and compare it to the specification numbers. And we got a bandwidth of about a little over 2 gigabytes per second. So okay, let's go ahead and shut down and move that card to a regular PCI slot. I won't be able to measure the power, but I want to look at what the file numbers look like in a regular PCI slot where we can run it in PCI 3.0 mode. All right, so we're booting up. I have the 9207-8E card in a different PCI slot. So let's just take a look at that. All right, so there is the 9207-8E, and it's at this address now, which is a different one than previous. And let's take a look at the card. Link status here is now 8 gigatransfers per second, so that's in PCIe 3.0 mode. And you can see that it is a SAS 2308 chipset revision D1, and that's the firmware, and it is a 9207-8E. Okay, so do we have all our SSDs? Yes, we do. We have A through H. All right. So being in that other PCI slot, obviously I can't measure the power consumption, but I want to see what the file numbers look like when it's running in a normal PCI slot. Okay, so we're still seeing somewhere in the area of like high 500,000 IOPS, which is somewhat higher than what we saw earlier, which was in kind of the mid to low range 500,000 IOPS. The throughput is about 2.3 gigabytes per second, so that's a little bit faster than what we saw earlier too. We'll see what the final average numbers come out to be. All right, so what do we end up at? For IOPS, we ended up at about 590, let's say 92,000 IOPS. So that's definitely higher than what we saw earlier by, let's see here. So it was previously 530, so about 60,000 IOPS more than when it was running in PCI 2.0 mode in the other slot. And the throughput was about 2.4 gigabytes per second, which is also a little bit higher than what we saw earlier in the other slot. Overall, not a huge difference. This number, the IOPS number, is still a little disappointing. I believe, going from memory, that the specification for this chipset was somewhere around 650,000 IOPS. So this is about 50,000 IOPS lower than that. Yeah, and I'm not sure why. And I think we saw something like this in the first video as well. I don't quite recall right now, but I think the SAS 2308 was a little bit shy of its specification numbers in the previous videos as well. But all right, anyway, time to move on to the next card. I'll record these numbers. We'll talk about all these numbers later on. But let me go ahead and shut down, and let's move on to the 9300-8E. Okay, so this is the 9300-8E based on the SAS 3008 chipset, and this should be able to get us to a little bit over 1 million IOPS. So let's see if we can achieve that. And this is also a PCI 3.0 card. Okay, so we're booted up, and let's see if we can see the LSI card. All right. There is the 9300-8E, and let's look at the PCIe speed, which is 8 gigatransfers per second. So it's back in PCIe 3.0 mode. I switched the setting to PCIe 3.0 in the motherboard. So okay, everything looks normal. Let's run SAS to flash. All right, so SAS 3008 chipset, that's the firmware version. This is a 9300-8E. Everything looks good. Let's check out the SSDs. Okay, we have SDA through SDH. All right, good. So I think we're ready for the file load test. But before we do that, let's take a look at the PMD2, and we're sitting at a 10 watt right now, pretty solid 10 watt. And so, all right, let's go ahead and run the load test. All right, so it went back up to, or not back up, but it went up to 11 watts. So this is pretty consistent with what we've seen with other SAS 3008 cards. We're currently at 1.2 million IOPS, about 4.7 gigabytes per second transfer. So in the past videos, we've gotten about a 1.5, 1.4 to 1.5 million IOPS out of these 8 SSDs. So this 1.2 thousand or 1.2 million IOPS is going to be, I think, the limitation of the card itself. Okay, so we're done here, and the average did indeed come out to about 1.21 or 1.211 million IOPS. 1.211703. Okay, so that's roughly 1.2 million IOPS, and for throughput we got almost a little shy of 5 gigabytes per second, so that's pretty good. All right, so definitely this is a much better performing card, pretty much more than doubles the 9207-8E. All right, so let me go ahead and shut down, and let's move on to the last card, which is 9400-8E. Okay, so this is the 9400-8E, and this uses the SAS 3408 chipset, which is the first generation of IOC chipsets that switched to the ARM architecture. So this should be more energy efficient, and I think the performance is just a little bit higher than the SAS 3008. So we'll check that out and see what we actually get. All right, so we're booted up with the 9400-8E, but I have to let you guys know that I had problems with it in PCIe 3.0 mode, and I was kind of expecting this because when we did the 9400-8i, that was a problem. It was the first time I encountered that problem, and so I had to set it to PCIe 2.0 for it to be recognized in that Elmore Labs PCIe riser, so that we can actually measure the power consumption, which is sitting at 6 watts right now. All right, but let me just show you that the card is here. All right, so here is the 9400-8E in that slot at the 03 address. Let me show you also that it is in PCIe 2.0 mode. So okay, so here's the 9400-8E, right? And link status is 5 giga transfers per second. It's identifying that that is downgraded because this is normally a PCIe 3.0 capable card. So we are running in PCIe 2.0 mode, and because of that, I'm also going to then rerun the FIO test with the card in a normal slot running at PCIe 3.0 just so we can compare and contrast, the file numbers at least, but I won't be able to measure the power. Okay, so one more thing. C0 show no log. Okay, so you can see that here again, 9400-8E. Here is the firmware version that I currently have. That's, I believe, the latest firmware available. And if you scroll further down, you can see that under the PD list, we see all 8 SSDs. And so if I run LSCSI, I should be able to see those 8 SSDs, SDA through SDH. And we will use this file script to run the 4K random read load test. Okay, so let's look at the power consumption. It is sitting at a pretty solid 6 watts right now. That's actually really, really good. I think the only card we've messed with in this video that was sitting at around 6 watts was the old 9200-8E. So this has brought that power level down to that second generation card. Okay, so under load, it dipped into a 5 watt territory. So this might be in the very low 6 watts actually. So all right, anyway, let's go ahead with the load test. Okay, so under load, it is hovering into the 7-watt territory. So it was in kind of the low 6 watts, now in the high 6 watts to 7-watt territory. We are hitting about 800, about 800,000 IOPS, about a little over 3 gigabytes per second in throughput. This is actually quite lower than I expected in terms of IOPS performance. I'm not sure why that is. My understanding is that this chipset should be about as performant as the SAS 3008, if not a little bit higher. So, okay, so we ended up at 818,000 IOPS, and throughput was a little bit, about 3.3 gigabytes, let's just say. All right, so, all right, let me shut down and put that card in a normal PCI slot and see what these numbers come out to be when we do that. I'm booted up with the card in a different slot, so it's visible in the O2 address. And you can see that right now it is in PCIe 3.0 mode at 8 gigatransfers per second. Okay, so let's just verify everything is there. All right, same firmware and all that, and the 8 SSDs are visible. So if I run LSCSI, they are, the lettering changed, so it's SDB through SDI. All right, so I gotta make some adjustments to, well, actually, no, I think my old, the original file script should be SDB through SDI. Okay, so I can use this one. Okay, so I don't know what the power consumption is, but let's see how the, if there's any difference in the FIO load test output. All right, so we're seeing 1.4 million IOPS. So definitely it seems to be doing better in a normal PCI slot. 1.5 million IOPS are there. Okay. So yeah, there's definitely a difference in the performance of this card being in a regular PCI slot and not in that Elmore Labs riser. Okay, so we are done here, and we got for IOPS on average 1.52 million IOPS. This is probably about the limit of those 8 SSDs. So I don't know, the specifications for this card are not very clear. They just basically say, hey, it's a little bit better than the last generation. And in the last generation, we got 1.2 million IOPS. So this is obviously better than that. It was 1.5 million. It is also very close to the limit of those SSDs, so it's really hard to tell what the limiting factor here is. So, and then as far as throughput, we are at about 6.2 gigabytes per second, so that is also significantly better. Let's put all these numbers into a table and have a discussion and wrap all this up. All right. Well, guys, here are all the results collected during the recording of this video. And I have to say that there were quite a few surprises in this round. And so let's go ahead and get started and kind of go over some of these results. So to begin with, we did the SAS 2008 card, which was a 9200-8E. This is a PCIe 2.0 SAS 2 6 gigabit controller. And the IOPS spec for this is, I don't know what's going on with the SAS 2008 cards, but there's obviously several models based on the same chipset, right? And, last time we've tested a 9211-8i, I believe, and this is a 9200-8E. And when I look on the internet on various Broadcom, or back then LSI documents, the documents seem to suggest different IOPS numbers for the different models. They all use the same SAS 2008 chipset. So I've seen numbers that were like, in a 300,000 IOPS range, like 360 or something like that. And there were numbers that were lower. And then this one, the documentation specific to the 9200-8E said 290,000. And all of these numbers have been wrong up until this point. So I don't really know what's going on with the official documentation from LSI back in those days. But you can see that we scored 413,000 IOPS when the spec for this particular model of card with the SAS 2008 said 290,000 IOPS. And the 413,000 IOPS is actually not surprising, because when we tested out the 9211 8i in part 1 of the series, that's roughly kind of what we saw. And so I was kind of impressed back then with the SAS 2008 cards. And here, yet again, I am fairly impressed with the performance capabilities of this really old SAS 2 chip. All right, so for bandwidth, we got basically 1,600 megabytes per second. And as far as the power spec goes, the nominal power consumption as provided by LSI documentation was 7.92 watts with a worst case scenario of 13.20 watts. We measured a 6 watt idle power consumption and under load 7 watts. And so that comes in a little bit lower than the 7.92, almost like almost a watt lower. Of course, we don't really have any detailed resolution into the, tenths of watts. So that could have been 7.9 watts, and it's showing 7 watts. But anyway, I think we're very, very close to the actual LSI literature on this. So anyway, continue to be impressed by this generation of card. It always seems to measure better than the specifications. And honestly, 413,000 IOPS is definitely not bad at all. I mean, that's much better. It's more than enough than what you need for hard drive based storage, and could probably handle some SSDs as well. Okay, so moving on, this was a big surprise. I did not anticipate at all that using the H221, which also has the SAS 2308D1 Rev D1 chipset, which is identical to the 9207-8E chipset, that it would score so poorly. And the IOPS, so, with the 2308D1, this is a PCIe 3.0 card. And of course, it supports SAS 2 6 gigabit. And the rating for this chipset is 650,000 IOPS. And we were only seeing 421,000 IOPS, which is, it's almost just tiny little sliver faster than the SAS 2008 card. And just that didn't quite make any sense. Also, this card's idle power was, in the 10 watt territory, and it really didn't change. Although, I mean, if you compare it to the nominal rating, which is 9.8 watts, it's it's pretty close to that. But yeah, I was really surprised that this card would perform so poorly, and I simply can't explain why. So anyway, we got 421,000 IOPS, quite disappointing. And the bandwidth came in at 1,722 megabytes per second. And as already mentioned, the idle power was about 10 watts with a under load power 10 watts. And, I don't really know how accurate these numbers are, because obviously something seems to be strange or anomalous about this particular card. And so I don't know how well I can trust these numbers. Is the load only 10 watts, or basically it didn't really change from idle to under load. The power consumption as measured by the PMD2 device didn't really change that much, and I don't know if that's because there's something else hindering the IOPS on this controller, so that basically we're not able to put enough load on it to increase the power under load. Maybe that's why the power didn't change, right? So it's really hard to tell. But obviously something anomalous is going on here. And so I'm really glad that I grabbed a genuine LSI 9207-8E card. As you can see in the following results, this, of course, is a PCIe 3.0 card. But then, I had the problem of this card not running in PCIe 3.0 mode. And so, again, that kind of throws a wrench into the results here. So when we're running this as a PCIe 2.0 card, this is a SAS 2 6 gigabit card, we were getting 533,000 IOPS. And this is rated for greater than 650,000 IOPS. So we were about, a little over 120,000 IOPS, under that specification. And for bandwidth, we got 2,179 megabytes per second. Now the power rating here, at least I think, was a little bit more sensible. It was idling around 9 watts and got into a steady 10 watt state under load. And that's kind of what I think we expect. That's kind of what we saw also with the 9207-8i card, which uses the same chipset, right? So strangely though, the 9207-8i card in the part 1, I didn't have any problems running that in the Elmore Labs PCIe interposer board, in order to measure the power. So for whatever reason, I'm having problems with the 9207-8e card. So that's also kind of strange. And when we put the 9207-8e in a normal PCIe slot where it can run in PCIe 3.0 mode, so that's this next line here, we got 592,000 IOPS. And that is, I think, pretty much on par with what we saw with the 9207-8i card in the first part of the series. And so at least that is consistent. That makes a lot more sense to me because, it's the same chipset. I kind of more or less expect the same numbers roughly, right? And so, running it in a normal PCIe slot, I think we basically got what we expected. The bandwidth number was 2,422 megabytes per second. And then, of course, running in a normal PCIe slot, we could not measure the power consumption. If you base it on the numbers that we saw in the PCIe 2.0 mode, and then, I guess combining that with the knowledge of what we saw with the 9207-8i in the first part of this video series, I think it's pretty safe to say that, yes, this card basically idles around 9 watts and goes into 10 watt territory under load. So, I think even though we don't have the results for when it was running in PCIe 3.0 mode, I think the results for PCIe 2.0 are pretty spot on with what it actually is. All right, so the next card was the 9300-8E. This is based on the SAS 3008 chipset, and this is a PCIe 3.0 chipset, and the first generation to support SAS 3, 12 gigabits per second. So this, I think, was one of the few. This and the first generation, the 9200-8E cards, were the only two cards that I think I have, confidence in the results because basically nothing weird happened. And so this is rated at above 1 million IOPS, and we got 1.21 million IOPS, which is, fairly consistent with what we've seen with other cards using the SAS 3008 chipset. And the bandwidth number we got was 4,955 megabytes per second. And the nominal power consumption as documented for this card is 14.5 watts with a worst case scenario of 22.5 watts. And as we've seen in the past with other cards using this same chipset, the actual measured power consumption seems to always come in less than what's in the Broadcom literature. And so we measured an idle power of 10 watts, and under load, it was only increased to 11 watts. Now, that is one of the more power-hungry controllers out there, but it's certainly a lot less than what we would expect from the documentation. All right, so moving on to the next one here. So this is the 9400-8E card, and based on the SAS 3408 chipset, this is the first generation of ARM-based IOC controllers. This is a PCIe 3.0 card, but just as we saw in the first part with the 9400-8i, I had problems running this in the PCIe interposer board, and so I had to change that to a PCIe 2.0 link speed in order for it to be recognized in that board. This card should be able to do more than 1 million IOPS, and indeed we see that in the second test here. But for whatever reason, in PCIe 2.0 mode, we're only seeing 818,000 IOPS, and this is supposed to be greater than 1 million IOPS. And the thing is, you could say, well, it's because there wasn't enough PCIe 2.0 bandwidth to allow that level of IOPS to go through. And maybe that's the case, So the bandwidth number we got was 3,346 megabytes per second. So like PCIe 2.0 by 8, I think is maxes out at about 4 gigabytes per second. So, 3,300, maybe take into account overhead and other things like that. Maybe there was some limitation running in PCIe 2.0. And so because of the bandwidth restriction, we could not pump in more IOPS into that. And so we're only seeing 818,000. The good news, I guess, and this is also consistent with what we've seen with other controllers based on this chipset. So the Broadcom documentation states that the typical power consumption for this controller is 9.48 watts, and we measured an idle power consumption of 6 watts with under load, it going up to 7 watts. And so this is coming in, I think, fairly significantly lower than what is documented, and I think that's a pleasant surprise. So I think if you're going after a power efficient card, really the two choices amongst the cards we've tested here are the second generation SAS 2008 or the 9200-8E, or it's this one, the 9400-8E. I think both of these are fairly energy efficient. Now, if you need the one that supports SAS 3, which is pretty advantageous if you're talking about inter-chassis communication. Basically, each link between your main server and a drive enclosure can carry a lot more bandwidth, supporting 12 gigabit SAS 3. So there is that advantage, and if you have enough storage that can utilize all that bandwidth, and also the fact that it supports PCIe 3.0. As you can see in the second test, we were able to pump over 6,000 or 6,200 megabytes per second through this card, running in PCIe 3.0. So if you want energy efficient, I think those are the two choices. If you want energy efficient and high performing, I think it's this card that you would want, the 9400-8E. Okay, when we put the card in a regular PCIe slot where it can run in PCIe 3.0 mode, we got 1.5 million IOPS, which I think is fairly consistent with I guess what the expectations are, right? Like the documentation was a little bit strange. I think I've mentioned this to you guys in the past, where the documentation basically says, this controller is a little bit faster than the previous generation, and without specifying any kind of number. And so the previous generation being greater than 1 million IOPS, we are certainly seeing that 1.53 million IOPS is higher than the 1.21 million IOPS that we saw in the SAS 3008 controller. And as mentioned, the bandwidth number was pretty good at 6,252 megabytes per second. I think that's getting pretty close to perhaps what the limit is for PCIe 3.0 by 8. Theoretically, it's something like 7.8 gigabytes a second, but maybe accounting for overhead and whatnot, maybe this is kind of close to that limit. But unfortunately, in PCIe 3.0 mode, we obviously could not measure the power consumption here. So anyway, that's the conclusion of all the results we got. A lot of surprises here in terms of, especially with the H221 and the way it was behaving. I wasn't really not expecting that to behave any different than the 9207-8E card. And so, that was certainly a surprise. And I guess it's maybe not so much of a surprise that, because we've seen this in previous tests with other controllers that use a SAS 2308 chipset, that it seems to be underperforming relative to the specification. And I don't really know why that is. So anyway, if you guys have any theories of why you think we got the results we got, I'd love to hear your theories. Leave your comments down below and let me know what you think. Why do you think the H221 was underperforming, even though it's using the exact same chipset? And and then why the 9207-8E seems to be having problems in that the interposer board from Elmore Labs, when the 9207-8I in the first part didn't have that problem. All right, guys, that's it for today's video. If you like this video, make sure to give it a thumbs up. And if you're new to this channel and you like this sort of stuff, consider subscribing to the channel. Also, if you want to support my channel, go check out my eBay store. I've got the best selection of pre-flashed IT mode HBA SAS controllers for your ZFS, TrueNAS, or Unraid builds. So go check out the link down in the video description. Thank you very much for watching and have a great day. Bye-bye.